Everyone, welcome to your Unit 6 notes on rational functions. Let's begin. Number 1. So number 1, I'm going to read the directions as I see them on the screen, and then I'll shorten them. Okay, so I'm not writing these down right now on purpose. It says the function g is defined below. Find all values of x that are not in the domain of g. If there's more than one value, separate them with commas. So let's just shorten those directions. Find all values of x that are not in the domain of g. Okay? And I have my function g of x equals x squared plus 4x minus 21 all over x squared minus 4. Okay? So I'm looking for the x values that are not in the domain. So the meaning of the word domain has not changed. Domain is your set of possible x values. Okay. So this is a rational function because it is a ratio. Notice those first 4 letters spell ratio. Fraction. So I have a numerator and I have a denominator, and the operation that makes this a ratio is division. So when I'm asking myself what values of x cannot be allowed, well, this is division. Ask yourself, what is the one number you can't divide by? Hopefully you just said 0, right? So if it's division, we need to think to ourselves, we can't divide by 0 so set the denominator equal to 0 and solve. Right? This will give you the x values that must not be allowed to be in the domain. So this numerator has no bearing on our question. We're focusing strictly on the denominator. Right, so let's go ahead and do that. We're going to set x squared minus 4 equal to 0 and solve. So there's actually 2 different ways that you can go about solving this. I'll show both, and you can pick one for your notes. First is to factor. From Unit 5, hopefully you recognize that this is difference of 2 squares, x plus 2, x minus 2. So if I set both of these equal to 0, x plus 2 equals 0, x minus 2 equals 0, subtract, subtract, add, add, I get x equals negative 2 and x equals positive 2. Okay. So in ALEKS, I would type in negative 2, comma, positive 2. Or, because there is no b term, it's just I have an a term, ax squared, and my c term, I can solve using square roots. So I can add 4 to both sides. So now I have x squared equals positive 4. Then I take the square root of both sides, and I get x equals plus or minus 2, or, as I would type it into ALEKS, 2, negative 2. Same answer, 2 different approaches. You get to pick which one you like best. All right? And whether the negative comes first or second, it does not matter. Number 2, simplify y squared minus 4y plus 4 all over 3y squared minus 12. Okay, so to simplify this, we need to factor. So all of those factoring skills from Unit 5 will pay off big time in Unit 6. So let's consider the numerator first. I noticed I have 1, -4, and 4, so there's no greatest common factor that I can factor out. So I need two numbers that multiply to +4, but add to -4. So if you're not comfortable, that doesn't just pop into your mind, on the side, we can factor, and then we can do our inner plus outer equals middle. So I have y squared, so y times y. 4, I have 1 and 4, 2 and 2. That one looks like it will get me to 4, right? 1 and 4 can get you to 3 or 5 in this case. So I'm going to use my 2's. So now I have inner plus outer needs to equal middle. So inner is 2y, outer is 2y. I need a -4y. So when they add, they have to come out to be negative. Therefore, they're both negative, and that works because -2 times -2 will give me my +4. All right. Now, if at this point with all of your practice, you can look at this quadratic and just immediately jump to y minus 2 times y minus 2, that's fantastic. I'm not requiring this work on the side. This is strictly if factoring is still not your strongest ability. Okay. So now let's factor the denominator. Now, if you'll notice, the denominator does not have a middle term. So immediately, let's actually make a note here. No middle term. So need to check for greatest common factor. Okay. So I have a 3 and a 12, which makes me think, hey, those are both divisible by 3. This has y squared. This has no y's, so I can only factor out a 3. Okay. Now, when you are factoring out your GCF, there's a couple of different ways of thinking about it. I will mention 2 specifically. Well, no, I'll mention 3. Okay. First, you can ask yourself, what times 3 is 3y squared? Oh, y squared. What times 3 is -12? -4. Now, as we move on through this assignment, we will see more intricate GCF factoring. So another way of thinking about it is that we are literally taking that denominator, 3y squared minus 12, and we are dividing each term by 3. The end result, well, 3 divided by 3, those cancel, leaving me y squared. -12 divided by 3 is -4. Okay. You can also do this division mentally, like a little mini conversation. 3y squared divided by 3, y squared. -12 divided by 3, 4. Okay. So this can be that thought process. Okay, let's continue. Are we done factoring? The answer, no. Why? Because notice, I have another difference of 2 squares. Well, actually, I shouldn't say another. It's the first time it's happened in this assignment. But this is a difference of 2 squares. Difference meaning subtraction, squares. Here's a perfect square, and here's a perfect square. So the numerator is still y minus 2 times y minus 2. Denominator, that 3 is still along for the ride. Y plus 2 times y minus 2. If you'll notice, I have factors in common, so those can cancel. And my final answer, y minus 2 over 3 times y plus 2. Now, Alex will accept this as an answer, or if you really want to, you can distribute that too. Y minus 2 over 3y plus 6. Okay, Alex will accept either. Okay, number 3. Simplify 4w squared x cubed all over 8x cubed plus 20 v to the 6th x. Okay, so we need to factor again. We definitely don't have something in the form of a quadratic, so we're not factoring like we factored quadratics. This is going to be another example of GCF factoring. So my numerator is just a single term. Therefore, I'm going to ignore my numerator for the moment. Really can't do anything with 4w squared x cubed. My denominator is a binomial, has 2 different terms, so we can look for a GCF. 8 and 20. Well, the GCF of 8 and 20, meaning what's the largest number they're both divisible by? Hopefully you just said 4. I would agree. Now, I have 3 x's in the first term, a single x in the second term. What is the most number of x's I can factor out? Just a single x. Now, that is one of the hardest parts of GCF factoring with exponents. So if that was confusing, or you're not really sure why it's just 1, think about it this way. If I have x cubed, I have x times x times x 3 times. If I have x to the 1, well, that's just a single x. So those only have 1 x in common. So therefore, I can only take out 1. Putting the 1 there as an exponent is completely up to you. Okay, now, the second term has 6 v's. The first term has none, so I can't take any out. Okay, now, let's factor out that 4x. There's 2 different ways of doing it. One is mental, one is algebraic. I will talk through the mental way of doing it first, and then I will show you the algebraic way of doing it on paper. Okay, so here we go. 8 divided by 4 is 2. X cubed divided by x is x squared. 20 divided by 4 is 5. Maintain that plus. V to the 6th divided by, well, there's no v's here, so it just stays v to the 6th. And x divided by x would cancel, therefore, I'm done. Now, in terms of taking out the greatest common factor, you know you've done it correctly if you look inside the parentheses and there's nothing in common. 2 and 5, no greatest common factor. X squared and v to the 6th, also no greatest common factor. Okay, we are actually not done simplifying though, because now that I've factored out of 4x, I can simplify the numerator and the denominator. Now this is important. Why can I simplify only these 2 pieces and not anything inside the parentheses? It's because these 2 terms are glued together by these parentheses. You are not allowed to cross off in any way, shape, or form anything inside these parentheses. The glue between these 2, however, is multiplication. So this you are allowed to simplify. Let me give you a simpler example. If I have 2 divided by 2 plus x, am I allowed to say, hey, look, there's a 2 up top, a 2 on the bottom, cancel, cancel? No, right? Because we understand that 2, what would that be? That would be saying that equals 1 over x. That doesn't make any sense. And if that example doesn't make sense, let's do it this way. How about 2 over 2 plus 3? Well, if I don't cross off anything, that's 2 over 5. I'm pretty sure we can all agree with that. Well, if I suddenly take that same example and just cross off the 2's, well, look I get a different answer. I don't get 2/5, I get 1/3. Right? So this is illegal arithmetic. because the operation gluing what you're trying to cancel, use a brighter color, notice, addition, right? It could be subtraction, right? Addition or subtraction, you cannot just cross things off. However, what if I had, so versus 2 over 2x? Well, notice now it's multiplication. So now you are allowed to simplify. 2 goes into itself once, and I get 1 over x. Similarly, if I had like 2 over 4x, well, as long as it's multiplication, you could tell me that's the same thing as 1 over 2x. That is completely a happy arithmetic legal move, all right? So coming full circle, can't touch anything inside these parentheses, but this needs to be simplified. And we're going to do it one term at a time. So 4 divided by 4, that's going to just be 1. Now, I actually recommend, as soon as you figure something out, write it down, because this can become really messy quickly with this whole crossing things off and putting new things. So ones, I don't need to put, so I'm good. W squared, no w's out front, so w squared is going to stay in the numerator. I have 3 x's on top, 1 x on the bottom. That's going to leave 2 x's in the numerator and none in the denominator. So there's none left in the denominator, and there's only 2 left in the numerator. Okay. Then this term was untouched, so it stays. 2x squared plus 5v to the 6th, and we're done. All right. Let's continue to number 4. For number 4, we need to multiply 10x cubed over a to the 4th x times 3a squared over 4x. Now, when we're multiplying fractions with variables, we get to simplify diagonally just like we would if there were no letters. So, an Algebra 1 example. If I asked you to multiply 12 over 45 times 9 over 24, initially you might go to reach for a calculator, but then hopefully you would hear my words saying, simplify diagonally. Notice 12 and 24. 12 divided by 12 is 1. 24 divided by 12, 2. 9 divided by 9 is 1. 45 divided by 9 is 5. Now when I multiply straight across, 1 times 1, 5 times 2, no calculator needed. So this same simplified diagonal technique will come in handy with something that looks much more complicated. All right? So first, let's look at our numbers. Diagonally, I see 10 and 4. Well, those are both divisible by 2. 10 divided by 2 is 5. 4 divided by 2 is 2. Okay. Now, at this point, we could simplify these x's. We could also simplify these x's. In my experience, there's much less error if after you simplify the numbers, right, there's a 1 here and a 3 here, can't do anything there. I actually recommend multiply straight across the top, multiply straight across the bottom, and then simplify your exponents. For some reason, it just seems to make sure that there's less room for error. Okay? So 5 times 3 is 15. X cubed times a squared, x cubed a squared. Remember, alphabetical order does not matter with these variables. Now we have a 1 here, so 1 times 2, that's just going to be 2. A to the 4th, I don't see any other a's, so that a to the 4th stays. I have x to the 1 times x to the 1, that's going to be x squared. So this cleaned up nicely. Final step is to simplify our variables. So 15 and 2 both stay in their respective spots. And that line's a little crooked. Okay, x's. There are 3 x's in the numerator and 2 x's in the denominator. That is going to leave no x's in the denominator and only 1 in the numerator. Now, this whole crossing off rewriting, completely optional. For some people, it really helps. For other people, it makes their paper too messy. So if you can mentally have that conversation, 2 x's in the denominator, 3 x's in the numerator, which only leaves 1 x in the numerator, that might be an easier process for your eyes to follow. Similarly, there are 2 a's in the numerator, 4 a's in the denominator, leaving 2 a's in the denominator. And I check, 15 and 2 can't be simplified, no variables in common, and we're done. Okay, if you are completely comfortable, go ahead and move on to number 5. If, however, it would be helpful to write some steps down here, let's pause for a moment and write down those steps. So, step 1, we simplified the coefficients, right? So these numbers in front are all coefficients diagonally. And if you don't think you remember what coefficients mean, we're really just talking about the numbers, right? We simplified the numbers or the coefficients diagonally. Step 2, we multiplied straight across. That should spell multiply. Multiply straight across. And step 3, simplify the exponents. Okay. Just a little reminder, when we're simplifying exponents in step 3, because we're dividing, make another little algebra 1 note here. If we have x to the 5th divided by x squared, that's x cubed because we subtract the exponents. When we're multiplying straight across, if I had x to the 5th times x squared, that's x to the 7th because we add the exponents. So here we subtracted, here we're adding. This is not to be confused with something like x to the 5th squared. Power to a power would be x to the 10th because we multiply our exponents. Okay, so power to a power we multiply, power times a power we add, And when we have a division situation, which you will come across a lot in this assignment, we subtract. Okay, moving right along to number 5. Multiply. X plus 3 over 3x minus 9. Hold on, that's kind of crooked. Sorry. X plus 3 over 3x minus 9 times x squared minus x minus 6 all over x minus 2. Okay, we have a lot of factoring to do. Technically, you could try to multiply straight across and then go from there, but you are actually working backwards. They've already broken this up a little bit. We want to keep breaking it down until we can't break it down using factoring anymore. Okay, so we're going to take this term by term. X plus 3, can't really factor that anymore. 3x minus 9, hopefully when you look at 3x minus 9, you immediately think that there's a GCF. So let's just take a bird's eye view here. For this denominator, I'm going to factor out a GCF. Over here, I see my quadratic. So I'm thinking this kind of factoring, right? Our double sets of parentheses. And x minus 2 is just x minus 2. Can't do anything with that. Okay, so let's take it from there. Some people prefer to go horizontally, some prefer to go vertically. I'm going to go horizontal, but feel free to do what works best for you on your paper. Okay, x plus 3 did not change. 3 and 9 are both divisible by 3. So 3x divided by 3 is x. Negative 9 divided by 3 is minus 3. If you are a very visual person and you would like to actually divide by 3 on your paper to see how we got x minus 3, that works too. Okay, one term down, one to go. X squared minus x minus 6. So I need my double sets of parentheses. Okay, x times x is 6. Excuse me, x squared. X times x is x squared. I need two numbers that multiply to 6 but add to negative 1. So some factors of 6 would be 6 and 1, 3 and 2. Well, immediately my eyes hone in on 3 and 2 as being two numbers that can get me to 1. So 3, 2. Now, at this point, if you are comfortable with factoring, you would immediately think, well, hey, these need to add to be negative 1. I'm going to make that bigger number negative and the smaller positive. If not, remember, you can always go off to the side of your paper with your x3, x2 setup and check inner plus outer. So inner is 3x, outer is 2x. I need a negative 1x. Bigger is positive. Excuse me, bigger is negative, smaller is positive, negative, positive. And one last check, negative 3 times positive 2 does give me that negative 6. Okay? All over x minus 2. Okay, we are done factoring. And all of this work will pay off. So, do you see anything that can cancel? Now, sometimes a lot will cancel, sometimes a little will cancel. What do you see? Okay. Hopefully you just noticed that I have an x minus 3 here and an x minus 3 there. Those will cancel. Anything else? No, no. Notice one's positive, one's negative. Those don't cancel. And 3 is just going to hang out for the ride. Okay, be very careful that when you're doing your final answer, you don't lose track of things. Okay, so I have x plus 3 times x plus 2 in the numerator, that's what's left, all over 3, there's my 3, times x minus 2. If you want to multiply this out, you can, but you don't have to. Alex will take this as the correct answer. If it was me, I would not go beyond this step for 2 reasons. 1, you don't have to. And 2, if you do, it's going to take up time and you have greater chance to make mistakes the more steps that you do. So let's leave it at that. Okay, number 6, divide. We're going to divide 10b cubed over a to the 5th b by, so divide by 4b over 3a squared. Okay, so I'm just checking to make sure I didn't make any transfer errors here. 10b cubed, a to the 5th b, divided by 4b, 3a squared. Okay, good. So you might be looking at this and saying, Ms. Beauchamp, you are crazy. How can I divide this? Well, the good news is you actually already know the math. Because, let's go back to arithmetic. If I asked you to divide 10 over 7 by, let's see, I don't know, 3 over 14, hopefully you would immediately think, keep, change, flip, right? We keep the numerator, or keep that first fraction, same difference, keep the numerator, change to multiplication, flip the denominator. So this would equal 10/7, keep the numerator, keep that first fraction, change to multiplication, flip the second, flip the denominator. And I notice 10 and 3, nope, can't simplify. 7 and 2, hey, those simplify. 7 and 14 would simplify to 1 and 2, giving me my total 23rds. Okay, if you can do this, you can do this, I promise. It's the same exact math. So step 1 is to use keep, change, flip for this situation. So this is going to be 10b cubed, right? We keep the first, nothing changes. Change to multiplication, flip the second, 3a squared over 4b. Now, number 6 looks exactly what we just did on number, let's see, what number was that? Number 4. Okay, number 6 now looks exactly like number 4. So if you want to go ahead and click pause, try this one on your own and see how you do. Okay, so step 1, simplify diagonally if you can. So 4 and 10 are both divisible by 2. So 4 divided by 2 is 2. 10 divided by 2 is 5. I have a 1 here and a 3 here. Can't do anything there. So I'm going to now multiply straight across. And I get 5 times 3 is 15. Number times number. B cubed times a squared is just going to be b cubed a squared. All over 2. I have 5 a's here, none over here, so just a to the 5th. B to the 1 times b to the 1 is b squared. Okay. Step 2, simplify the exponents. So in the numerator, I have 3 b's. And the denominator, I have 2 b's. So you want to ask yourself, how many are going to be left and where? Numerator, denominator. Well, our 15 and 2 aren't moving, so let's just put those down right away so we don't have to worry about them anymore. Back to my question. 3 b's on top, 2 on the bottom. Hopefully you said that leaves 1 on top. Next, let's look at the a's. I have 2 a's on top, 5 a's on the bottom. How many is that going to leave and where? Hopefully you said 3 in the denominator. I checked my answer. Is it as simplified as possible? See, 15 and 2, A's and B's, nothing in common. I am done. Number 7, divide. Okay, we are going to divide x plus 2 divided by x squared minus 4x plus 3. We're going to divide that by 4x plus 8 over x squared minus 3x plus 2. Okay, we have factoring all over the place here. So step 1, okay, you actually have a choice here. You can factor, then do keep, change, flip, or you can do keep, change, flip, and then factor. Personally, I recommend do keep, change, flip first, because in my experience, you won't start canceling things incorrectly. Okay, so let's keep, change, flip this question, and then we will get into factoring. So keep the first, change to multiplication, flip the second. So in terms of what kind of factoring here, x plus 2, can't do anything. Here we're going to have our standard quadratic factoring, and GCF. Okay, you should be really good at this by now, so please click pause and try to factor on your own. Only click play if you've tried to factor on your own. Okay, let's see if we match. So for me, x plus 2 didn't change. In the denominator, I have x times x is x squared. 3 is prime, that's nice, so I know it has to be 3 times 1. Has to multiply to a positive 3, so either they're both positive or both negative. I look at my b term sign to determine. I see that that's negative, so they're both going to be negative. If I want to check inner plus outer equals middle, I might do it on my paper or in my head. It's up to you. Negative 3x, negative x. There's my negative 4x, but negative times negative is positive. Okay. Again, this is completely optional. For the purposes of these notes, well, I'll leave it here. I'll leave it in this case because it's not in the way, but just know that that's entirely optional. Okay? Times x times x is x squared. 2 is prime, so I know it's 2 and 1. Both positive, both negative. B term is negative, so I know they're both negative. Okay? All over. GCF of 4 and 8 is 4. So 4x divided by 4 is just x, plus 8 divided by 4 is 2. All right, all the hard work is done. Now I just need to cancel carefully. So let's look diagonally. X plus 2, those cancel. Side note, I recommend put a 1 there because sometimes terms will start to move around when they shouldn't. It's not that there's 0 there. There is a 1 there, so keep a 1 there as a placeholder. Anything else cancel? Yes. Look at this diagonal. I have an x minus 1 and an x minus 1. Okay, so to get our final answer, we can now multiply straight across. My final answer, 1 times x minus 2 is just x minus 2 over 4, don't lose that 4, times x minus 3, and you're done. Remember, you can distribute if you want. Alex does not require it, so neither am I. Moving right along to number 8. Okay, number 8. What is the least common multiple of 5x cubed and 8x squared? So this is actually a review question. LCM for least common multiple, so if you want to just make a note, LCM. And GCF show up all the time on the AccuPlacer, so we will always be bringing these questions back. Go ahead and click pause and see if you can come up with this one on your own. What is the least common multiple of 5x cubed and 8x squared? Okay, hopefully you said 40x cubed. So multiple, think multiply. If you didn't match me, let's talk about it. If you did, go ahead and fast forward to number 9. So if I look at multiples of 5 and 8, I'm going to count up by the bigger number and stop when I hit a multiple of 5. 8, 16, 24, 32, 40, there it is. Let's just do one more for good measure. Let's pretend 40 did not stick out to me. Well, now I start counting by 5s. 10, 15, 20, 25, 30, 35, 40. Hey, look at that. 40. So that is the least, meaning smallest, common to both lists, multiple. All of these are multiples of 5. All of these are multiples of 8, and they have it in common. For the least common multiple of x cubed and x squared, just remember it's always going to be the largest exponent, not the smallest. Okay. A little side note, GCF of x cubed and x squared, that's when you ask yourself, well, hey, that's 3 of them versus just 2. They only have 2 in common, so the GCF would be x squared. For the least common multiple of x cubed and x squared, it's the larger of the 2 exponents, because x squared times x to the 0 is x squared, and x cubed times x to the 1, actually no, that's not true, back up. X cubed times x to the 0 is also x cubed. Okay, so least common multiple, x cubed. I'm not really sure I like my explanation of that just now, so I'm going to erase it because I don't like it. For now, let's just go with x cubed because it's the larger exponent. And I will have an alternate explanation ready for you tomorrow in class. Okay? So least common multiple, go with the larger exponent. Greatest common factor, think about the diagrams that we've been sketching before. Number 9, subtract. And I'm going to actually write this exactly how Alex does on the screen. As a negative out front, so 4c minus 9d over 4c minus 7c plus 11d all over 4c. Okay, we are subtracting fractions. So when we subtract fractions, we need common denominators. So when subtracting fractions, we need common denominators, which we have. Look at that, 4c and 4c. So that has been done for us. Now, let's talk about these negatives. This negative really applies only to the numerator. It does not apply to the numerator and the denominator. This is actually something you already know. Because think about if I wrote negative 3/5. Well, we would understand that that negative applies to the whole fraction. If it applied to the numerator and the denominator, well, all of a sudden you've turned this into a positive 3/5, which doesn't make any sense, okay? So instead, an acceptable move that I think we would all agree on is if I have a negative out front, well, that's no different than -3/5. Typically, that is a little easier on our eyes than having that negative sign in line with the division sign. The key here is, though, it does not go to, sorry, I got tongue-tied there. It does not get distributed to the numerator and denominator, it's just the numerator. So, back to our question. I now have -4c, negative times positive, plus 9d. You know what, let me actually move this over. Over 4c. Now here, be careful. This is what messes everybody up. Even though there's no parentheses, remember, this entire numerator is being subtracted. And because I have common denominators, you can actually just go ahead and extend that line into one fraction. So -7c minus 11d. And I got that because I distributed the subtraction. -7c minus 11d. And because I already have common denominators, I can turn it into one fraction immediately. So what's left to do? Combine like terms. So I see a -4c and a -7c. Don't want to make that c look like a d. And then I have my 9 and 11d's. So let's combine those one at a time. -4 minus 7. Don't say 3. Be careful. Negative minus negative becomes a bigger negative. So I have -11c, positive 9 plus 11. Oops, I said c and I wrote d. -11c, excuse me, minus 2d all over 4c. Okay, question, can I cancel those c's? What do you think? Hopefully you just either shook your head no or said no out loud, because notice it's being glued together by subtraction, which means that there's like invisible parentheses grouping this together. You cannot cancel those c's. Oftentimes in this assignment, people will take a perfectly correct answer and then ruin it by just continuing when you're done. Okay, so this is done. Don't touch it. Nothing else can cancel. You're good. Okay, so that was numbers 1 through 9 of the notes. We are a couple minutes past a normal class period, so I'm going to stop there and continue with numbers 10 through 18 in the second set of notes.